Hello everyone, and thank you for being here at this presentation today. We've had 2 days of our summit. Right now we are at the peak, and with 2 days still to come. And we are in Boston, which is a smart city. We'll talk today about the case of Messina, which is a smart city. I'm Cristiano, product manager at Fujitsu, and I will tell you about the product part and the business side of this case study. Together with me, there is Giovanni, a researcher at the University of Messina, and he will take care of infrastructure and the demo, as you can see. Sorry for the delay, but so we'll try to have a quick demo to show you what we are doing in Messina. And Vitek, senior software engineer at Fujitsu, he will explain the architecture and some challenges we found during the project. So we're talking about smart city, which is an example, a type of Internet of Things. Indeed, this is, if you type right now Internet of Things, that's what you can see in the internet. Just to be sure, who knows what Internet of Things is? Can you raise your hand? Okay, everybody, fortunately. But I want to be a little bit trickier here. So if we ask the same question, what is Internet of Things? If we Google, for example, Internet of Things 5 years ago, what would be the result? Do you have any idea? It's a bit trickier. So if we do that 5 years ago, we will find Illuminates of Thanateros, which is a global magical organization, and International Oceanic Travel Organization. So if you can see, 5 years ago and today the situation is dramatically different. But it's back in time that we need to go to start our case study. Indeed, everything started in 2014 with brainstorming. As we said at the time, Internet of Things was basically an idea. So we sat all together to try to understand what could we do in order to exploit this opportunity in the city of Messina. The first step then was a crowdfunding action. If you see the image, we can see smart city from different perspectives. Could be smart energy, smart building, maybe crime prevention, maybe Snowden would be interested in this one, and so on. So then the idea was to try to put all these different perspectives all together in order to work together and to exploit this opportunity. Of course, then some organization, maybe an organization has more skills in smart energy, and then they would have bring their own devices on that, on this project. And then we needed to have an infrastructure that could handle all this information all together. The crowdfunding action was actually very good. In fact, it exceeded the expectation. Therefore, it was possible the following year to start with the development. Development, which is more or less as described in the picture bottom right. So there are the Internet of Things devices all over the city of Messina. For example, as we said, organizations that are skilled in smart energy could bring those devices. Or also the city itself had some devices that needed to be used again. This is why the first challenge we found was how can we get the information from all the different devices, collect all of them, and put them in one unified point. This is indeed the goal of Stack4things, the second layer that we have. Indeed, Stack4things serve to connect the devices with the underlying cloud. We're talking about Messina, crowdfunding action, community. Therefore, the natural choice for the cloud is OpenStack. Another challenge that we found, Internet of Things devices, there are devices everywhere, is to monitor the health of those devices. Even more, another challenge, big challenge, is to collect different information, analyze there over time, and to try to understand if some devices can have problems, to predict anomalies. This is why we choose Monasca. Then we arrive to nowadays where we are in operational and enhancement status. So the project is live, more projects are to come, and yeah, we can see what is Messina right now. So here, this is the city of Messina. As you can see, it's in the middle of the Mediterranean Sea. weather is warm, food is great, people is friendly. So if I can give you a tip for your next holiday, come and visit Messina, because if you go through the street of the city, you can see the device like that one top right. So there are these devices all over the city that serves to collect information for example, 4 of these projects that we underlined here: urban mobility and e-tourism, and in particular, the last 2 projects, environmental monitoring and device fleet management, are the goal of the demo that we will do soon. I will hand over then to Giovanni, who will explain a little bit more about the infrastructure, and will give the demo. Bella.
So first, an introduction about the kind of devices that Cristiano was talking about. This is just a sample of the kind of devices which are available throughout the city of Messina, but it is a sort of first prototype of a system for environmental monitoring and data collection. In particular, it's an Arduino Yun device, which means having a microprocessor and a microcontroller on the same board. Coupled with a Tinkerkit shield, which is a way to really break out the whole I/O, the pins available on the system. So being able really to attach any kind of sensor very easily, because it's really a plug and play experience. And in this case, we are talking about thermistors, about brightness sensors, about sensors for noise, environmental noise, and so on. But this is just the first kind of devices involved. We are expanding onto different other more powerful systems. We already have used in the field Raspberry Pis and other systems which are, let's say, under the single board computer category. But we are also expanding on the mobiles, in the sense that the mobiles are meant to be part of the infrastructure, as we'll see in a moment. So in terms of the architecture, this is the board side architecture. So we have really what is called the lightning rod, which is really the agent on the board, which is its main goal, of course, is to interconnect the device with the cloud. What it does is it is able to, of course, receive and send data, commands, streams. It's also able to instantiate virtual networks, but this is something more advanced than at the moment is prototypical, and it's only available on a special flavor of this environment, which is a Node.js-based prototype. But the main goal, especially talking today, is about being able to really change at runtime the purpose of the device. So having a plugin loading system. So really what we call a Stack4things plugin is just a way to really have user-level business logic which can be deployed, we say injected at runtime on these devices. And of course, okay, we'll skip the lower layers because they are dependent, of course, on the particular system we are talking about. In this case, there's an abstraction layer which is file system based and is based on a kernel module for Linux, which exposes GPIO really as virtual files on a sysfs pseudo file system. So this is the cloud side architecture. This is the architecture of what we called IoTronic. Sorry for the pun, but it was not really intended. It was a sort of a code name for the project. It got stuck. But anyway, the idea was exactly that, in the sense that we wanted to have these devices as a bare metal of the infrastructure, of course, distributed infrastructure, and so we really modeled that after, of course, an OpenStack service, so it's really designed as such. We have, of course, the APIs, which are available through a command line client and through a dashboard we'll see now, so through the web browser. We have the conductor, which is really the core of the system, so really what is tasked with ingesting, of course, API calls to dispatch really messages among the different components we'll see now in a moment, and of course to persist on the database all the information concerning the metadata concerning the IoT devices, so really the identifiers and other metadata which is useful for the user. In this diagram, there's a part which is already available in the OpenStack Compliant service, which is the WAMP agent, which is tasked with the data and command stream, as we have said in the previous slide, and the part, the tunnel agent, which is really meant for the networking part, the more advanced tunneling system. Both are based on WebSockets technology. In fact, it's WS tunnel, and WAMP, which is really a sub-protocol of WebSockets, and its purpose is to provide publish-subscribe system and also rooted RPC. And so now we get to the demo, hopefully.
I hope everything goes well.
Okay, not now, I just tell you. Okay, first of all, let's see if we have the devices already available. Okay, let's first switch then on the dashboards. Okay. First of all, the introduction on the dashboard we just mentioned. We have a new panel which is called IoT. This is where we can see information concerning the boards, as we have seen. So, as we have said, so we have here Boston 6, 11, 39, and 48. At the moment, we see that they are offline, but because they didn't connect, and I will see in a moment. But anyway, here we have the descriptions of the metadata about the system, like the kind of device or a UN. We have the location, and then we have a list of plugins we'll see in a moment. What we can do here is, of course, okay, also looking up the information for the geolocation, and we can create a new board in the sense that we can really put up a new board which is meant to be an instance of a board which will get really populated when the board really gets switched on and registers to the cloud. We can delete boards. We can remove plugins from the board, and now we switch to the plugin list. Here we see the plugins. We have the owners of the plugin, in this case, for instance, the admin. Public, if they can be visible for all the users. Callable means that the kind of plugins which really are callable, so true, are those which are really sort of an RPC. So we really have to inject that kind of plugin and then call and receive the response back. Whereas we have what we call asynchronous plugins, where we can inject the plugin, we can start, stop that, and of course, for any plugin, we can remove from the board. And we can click on a plugin and see the information about the plugin, including, of course, the code. And the user, of course, this is a user-level code. So as a user, I can create a plugin and copy-paste the code I have. Okay, and in terms of identity as well, we have a project which is called Boston. We have users, including one under my name, but what I want to see is that we have new roles which are especially meant for this kind of treatment. So we have an admin of an IoT project and a manager of an IoT project. Then we get to the monitoring part. This is really the Monasca panel integrated in Horizon. And here we have the links to the metrics, the board's health, the Monasca health, and the log management. And here the services should appear. Can switch on the clips. No, yeah, I switch on the clips because it's not working. No, switch to the clip. Offline. Non si sono collegate.
Ok.
Forse non ha preso qui. Non lo so.
Okay.
Questo non è collegato. Ecco perché. Sorry, it was just a
network problem.
A network problem, but it's no way. Okay, so just leave us. Okay.
We saw something similar this morning during the keynote. So.
Okay, so just a few seconds and. Okay, anyway, good. We can at least see it live. We'll see now in the monitoring section the boards coming up. Of course, let's give them some time. Just to give some perspective while we wait for this kind of devices. Okay, here, look, there we have a way to see. These are what are called Linino boards because there's really a Linino environment, which is really a sort of a flavor of a minimal Linux distro. In particular, is derived from OpenWRT, which is famous for routers. Okay. Wait. Okay. Just to. Okay. Not yet here, but maybe it's because we need to. Okay. Let's. Okay. Okay. Now we are injecting the Monasca plugin. So let's see the boards first. Okay, the boards are still not connected. Want to switch to the clips? Okay, let's switch to the clips that we have recorded, because problems happen. So anyway, you can see here, wait, I'll try to skim through the parts. Okay, here I'm doing what I was expected to be doing. So I inject the Monasca plugin, which is really a plugin meant for, as you can see, sending metrics, and we have a polling time. It is meant to be different for each board in order to have, let's say, different timings, because it's, let's say, part of the demo, as we'll see in a moment. So 25, 20, 15, 10 seconds. Okay, then here we have the graphs. Okay, here we have, for instance, okay, what was called the board's health. So also the monitoring with respect to the resources. So in this case, CPU load, RAM pressure. And okay, here we see, okay, what we would have, okay, is this. We would have, okay, this one. So you see that we have really the green ones, which are the ones which are online and are monitored. So then we can see that we have alarms, and you can see that the status is okay. Alarms which are custom configurable, in particular configured for a certain threshold over, for instance, temperature, which was the reason for the lighter. And And okay, here we get also to the visualization stages. So back to Grafana. So okay, here we have some heat maps. We also have the real-time graphs. We can't see them because they are not in the recorded video. You have the Monasca Health. Monasca Health is really the health of the Monasca system, really the Monasca service in the cloud. And okay, here we have Kibana, which was the log management part. In the log management part, we can filter, for instance, the kind of device by log level, for instance, and then, as we can see, by host name. And so have a look at a specific board where we also have encoded as messages the measurements to have another avenue to really have data streamed and persisted. And okay, let's go a bit forward. And okay, the ultimate goal also on the Kibana side in terms of visualization was having a look at the 4 boards all over Boston with different kind of dimension of the circles and of the shade, meaning, of course, the count, the number of samples arriving. So the idea is with as we can see now, with the lighter part of the demo, that okay, so just to give an explanation here, we have also the logs in real time over the shell, just to look at them. What happens is, okay, I'll light one of the temperature sensor, just put near the temperature sensor, but the idea is that one of these really, upon triggering of a certain event, in this case a threshold over 30 degrees, for instance, just in a moment, the logic in the plugin was, okay, please restart, reload the plugin in the other nodes in the area with a different polling time, really a quicker frequency, because we are talking about a critical event. It could be a sort of, let's say, fire incident, and so we want to be sure that we are tracking really the phenomenon. Okay, and so we can see that there's rebooting Monasca plugin. You can see, I stop at a moment just to have you look. And so we are restarting the plugins in the other systems. And so, okay, we can also see that there's the alarm. We can see that there are the spikes over the whole graphs. And we can see also that the count increases more quickly in the boards, and they tend to be more leveled. Of course, it's not that dramatic this way, but you get the idea. Okay, then, okay, the count, we have shown that, so we can skip this one. So this was just to give a bit of a context from where we started. Cristiano told you that we had this Smart Me crowdfunding initiative. What we had is, okay, we have at least issues with visualization because we have a sort of a built-in solution, we developed in-house. And so we wanted really to have something more powerful. This is really the kind of dashboard that we built on our own, and so we have, of course, the measurements, we have the historical data, we have ways also to see, let me check, not here. Okay, here again. Okay, that was to have you see that also on our map we had the update of the data. But what I wanted to really show you was that really we have, okay, here, maybe, yeah. Here is, again, our homepage and the dashboard we have for SmartMe. But here we can really zoom in, have the data. We have the last sample. We have historical data. We have some graphing also here, but it's not real time. This is just, okay, this is connected to an open data system in order at least to have a way to really make it public for government and other interested citizens. Okay, and that's it for this one. Just a quick, okay, not here. Let me have a look here. Just a quick look at the other system that I told you before, the standalone version of Iotronic. This one has some more advanced functionalities. Just to know about, we for instance have the possibility to SSH in the system through the cloud by a tunneling system. And we have sort of a very little version of a network management system resembling, in a sense, a Neutron, in the sense that we put up virtual LANs among this system over WAN, and so we are able really to interconnect these systems on the fly. Okay. And I think it's done with them. Yeah.
All right. Thank you. Yeah, so in case of smart city implementations, I think it's quite obvious that with time your environment will grow. You will get more objects to observe. You will have more devices, more measurements. So you need a solution, a scalable solution, to collect all this data, to organize it, analyze it, and visualize. And because Stack4things already integrates with OpenStack, Monasca is a natural choice to achieve these tasks. And Monasca stands for monitoring and logging as a service at scale. And indeed, we put a lot of emphasis on high performance, scalability, and fault tolerance. We achieve it by design. Monasca follows microservice message queue architecture. We have a number of big data technologies which we use, like, for example, Apache Kafka, which is massively scalable message queue, well established in big data projects. It is highly performant. It can handle millions of messages per second. Then we have a Threshold engine, which uses Apache Storm. It is distributed streaming processing calculation framework. We use it to evaluate alarm expressions in the Threshold engine. And then we have InfluxDB to store the measurements. It is at the moment one of the most performant open source time series databases. Last year, end of last year, they published the results of their benchmarks. So on a single AWS instance, they measured 900,000 values per second write throughput. Yeah, so I will not go into detail to all the components. Well, in this diagram, we can see at the top the agent. It is, in that case, a custom agent because of the limited resources which are on the board. It is installed on the device. It collects the measurements and also monitors the healthiness of the system. We also have at the top left the dashboard which you have seen, and we integrate with a Grafana dashboard so you can visualize your data. One feature I would like to focus a little on is that in the context of IoT measurements, the measurements they are different from when you're monitoring an OpenStack system, for example. So they don't come in regular periods of time. You have long periods when you get just a few measurements. You have other periods where you get many measurements. And with the traditional aggregation functions which we use in Monasca, like average, sum, min, max, you also need a constant evaluation period to evaluate the alarm expression. And to handle this sporadic, occasional metrics, we use the last function, we don't need then this evaluation period. We just take the last measurement which is known, and it also has the advantage that the transition, if the threshold is exceeded, occurs immediately after the measurement comes in. All right, that's all for me.
All right. So then I think for next time we'll be take care that all the cables are plugged in advance. So we'll try next time to do better. I want to tell you about the current status and the next steps of this project. We are working on 6 projects, European projects, for about $60 billion, and we will do that for the next following months. We see that there are more and more projects and products that we want to integrate. So we're growing. There are more use cases, more challenges that are arising, and therefore we think that combining our projects with other OpenStack projects could be a good solution for us. Also, in the next future, what we want to do is, one of the issues that we see is deploying applications in the devices and in the cloud. So what we want to do is to monitoring all this information, so from the application point of view. That leads us to the end of this presentation. Just to wrapping up, we have seen the case study, architecture, a sort of demo, and the next steps. And right now, I think we have a little bit time for question and answers, if you have any question.
So I'm just wondering, what did you exactly use for thresholds?
Could you please speak to the microphone?
Hi, Yuri Kutan. I'm just wondering, what did you exactly use for the threshold processing?
As I said, we use Apache Storm. So the component we use is called Monasca Threshold, and it uses Apache Storm.
Okay, and it's just some sort of straightforward linear threshold setting, not like correlation or whatever.
No. So
Okay.
you can create compound alarms, defining alarm expressions for different metrics. You can do that. You can combine them with logical operators, but we don't do really correlation.
Okay, thank you.
One of example of what we do is also with complex event processing, where we combine different types of metrics, different types of logs all together and create an alarm on top of that.
Quick question on the Monasca. How it is different than Ceilometer? Means I'm just trying to figure out what it is collecting, and Ceilometer also collect kind of similar stack. So, means what would be the difference between Ceilometer and Monasca?
So I think technically with Monasca you are able to have much finer granularity of your measurements. You can collect like every 5 seconds a measurement over a long period of time, and you can store all this data. The system is really performant, so you cannot achieve this with ceilometer.
Any other questions, or we good? All right. Great. Thank you very much. Thanks a lot.